There was a long time when Maine was like many, many years behind the updated code, and now we're catching up.
In the building science world, the joke was always that the code was always the worst possible house you could legally build, and it was. For the most part, wasn't really that great. But at this point, it's gotten pretty good. You know, code is really much higher standard than it ever used to be.
So what does it mean? 2021, basically, if you boil it down, is a 10% increase in energy savings since the 2015 code. Doesn't seem like much, but over time, it makes a difference. So it's 40% better than it was in 2006. Getting closer to, you know, kind of what I consider the ultimate standard, which is passive house. It behooves everyone to understand what that is, because we're going there. Not to scare you. Don't look scared, guys. It's good. It's all good. It does mean, you know, you got to learn a few new things. That's why you're here. Maine has 2 climate zones, Zone 6 and Zone 7. Anybody do any work in Aroostook County? It's just a lot colder up there, so the energy standard is a bit different. What is MUBEC? Anybody know what MUBEC stands for? MUBEC, Maine Uniform Building and Energy Code, references all these other codes, IECC, International Energy Conservation Code, and then there are Maine specific amendments that makes it unique to here. This is what Maine uses as its code, but it's not a code book. It references other code books. The state makes some modifications to those. Even though it's a code with all these standards, there are different ways to achieve the standard. Prescriptive means you follow what they say in the code book for all of your assemblies. So it's going to say you need to meet a certain R value in a wall and a roof and a floor and on a window and for ventilation and for mechanicals. And you just follow what they say to do, and that's fine. That's prescriptive. It prescribes what you do. The prescriptive is maybe a little bit easier, like you just check off all the boxes, you're done, but it's not as flexible.
The main point here is that when you go to reference Maine codes, you have to not only look at the IECC code book, you also have to cross that with the Maine specific amendments. So right now it is a cumbersome process. You have to look at the base codes and then also the Maine specific amendments to have your total code book. The stretch code says a 15% improvement.
What does the code cover? There are different classifications based on how many units or how many stories you're building. Some examples: prescriptive, so you comply with those sections plus 1 additional efficiency package option, or you do the total building performance option and 1 additional efficiency package option.
Essentially, if you make your building 5% better, you don't have to add that additional energy package option.
There's an energy rating index, which gives you a couple of options. And then MUBEC has adopted alternatives. There's this whole other thing called DOE Zero Energy Ready Homes, which is its own certification process. And that you can use as another way to do it. Or FEOS or Passive House certification. They recognize that. So many options. I mean, you just got like loads of ways you can do this. The additional efficiency package options you could look at are enhanced envelope performance option. So more insulation in your floors, walls, and your roof would cover that one. You could also get more efficient HVAC equipment. That would be a higher performing heat pump or boiler or whatever it is you're using. Reduce energy use in service water heating option. Domestic hot water. After your heating load, your domestic hot water is generally your next biggest load in your building. More efficient duct thermal distribution system option. This is where I think you really have to pay attention to any ductwork that's outside of the insulated envelope. If you've got ducts in an attic, in a cold attic, you have to really insulate those things well. Improved air sealing and efficient ventilation system option. Build tight, ventilate right is the mantra. So do houses need to breathe? Yes, they do, but not in the way we traditionally think, not through the walls and the cracks and the floor and the foundation where like you get all kind of nasty air coming in. We want to control where it breathes. And it's going to breathe basically through 1 duct that goes to a ventilation system. And that ventilation system ideally has energy or heat recovery as a part of it. And it takes outdoor fresh air and distributes it to the house, and it takes stale air from typically the bathroom and the kitchen, goes to this box where you have heat recovery. So the outgoing warm air is heating the incoming air, and then it exhausts that stale air outside. Prescriptive compliance option. There's tables that you have to follow. Meet these different criteria for insulation value. Everybody familiar with the term R value? It means resistance to heat flow. The higher the number, the better insulating it's going to be. Well, U value is just the inverse of that. So you take 1 over your R value, you get the U value, but that shows heat transfer. Here's the table. If you want to do prescriptive, here's the table you go to. Fenestration, that means windows and doors, and you got to hit that U value. Again, U value, the inverse of R value, so 0.3 is like, U value is 3.3 R value, 1 over 0.3, 3.3. So lower U value would be better. Then jump over to ceiling R value. In 2015, it was R49. 21, it went to 60 in climate zone 6. This is what we're looking at. So now your ceiling or roof R value has to be 60. That's like, 16 or so inches of cellulose insulation.
Exception to be noted for ceiling insulation is that if your insulation covers 100% of your ceiling and up over the top plate, you can actually reduce your R value to R49.
Insulating over the top of the entirety of your wall is really important for that the continuity of your thermal. You want to think about your building as like this really thick blanket on the outside. You want to go up the walls and the roof and down the other side and around the bottom. So if you take your insulation out over the top of your wall and fully cover that to R49, I guess, you're good with R49 across the whole way. Current code has been for a while, you have to build a wall that there's like a typical stud wall, right? 2x6 stud wall, you can get R20 in that with some kind of fill, bat or dense pack insulation in that. But it's also said that we have to manage what's called thermal bridging. Thermal bridging occurs when you have cold, let's say cold, that passes through a material, right? And wood, even though it's not very conductive, there's still an amount of cold that will come through a stud and get into the inside of your house. So the way to make that better is to put more insulation on the outside of that stud in the form of continuous insulation that reduces that thermal bridge. So now it's harder for cold to get into those studs and move to the inside. In a typical wood-framed building, I think like you have your insulation, that's great, that has an R value of say 20, but that stud has an R value of like 5. And if you add up all that wood in that assembly, it's going to be like 30% of the total assembly. So only 70% of your building is performing with that R20. The rest of it is performing at R5. So it kind of knocks the whole thing down significantly. So by putting that insulation on the outside of those studs, you're greatly reducing your overall energy transfer. You can also just make a thicker wall. So in the current code 22.1, you can do an R30 overall, or they've increased the continuous insulation to now it's 10. So R10 on an R20 cavity. If you go to a 2x8 stud wall, that's going to get you like R25. So that's not quite going to get you R30. So this is where you use your creativity to figure out how you're going to get to those assemblies that you need to get to.
So when we're talking about the wood frame wall R value, again, it's really important to cross-reference the Maine state amendments with your IECC codebook, because you'll see that it says 20 plus 10 here. The 10 is in red because that's a Maine specific amendment. If you were to just look in the IECC codebook, it'd be 20 plus 5.
So you've got moisture flowing through a wall. In the good old days with no insulation and like everything's just a wooden board, moisture just flows in and out, dries out all day long, all seasons, totally fine. That's why old uninsulated farmhouses in Maine, if they were built well, are still around. The problem is when you start putting things in that wall to change the dynamics of that moisture and temperature. Then you start looking at where do we not want moisture to potentially form. And in the way we build, we have like a stud cavity and we have sheathing on the outside of that. And that's usually the danger point there, is that sheathing layer, because it's gonna slow down the transfer of moisture enough that if it's cold enough, the inside face of that sheathing can start to get moisture forming that can do damage to that material. If you put enough rigid insulation on the outside of that sheathing layer, you're going to keep it warm enough. So you're not going to hit the dew point. The dew point's going to happen somewhere outboard of that in the foam where it's not going to be a problem. The other thing that will save your butt is if all of your exterior insulation is vapor permeable. And that's another thing you can look up on a chart, like what's the vapor permeance of different materials. EPS, XPS, mineral wool, cellulose, wood fiber, they all have different permeance ratings. And if you keep everything really nice and permeable on the outside, the moisture that gets to that sheathing layer can pass through and be harmless. Another good tactic is to have an airspace between your exterior insulation and your siding, known as a rain screen. And it's just good practice for bulk water management, but it also helps vent any moisture that might get in that cavity, just like we vent roofs, vent your walls. You can do it by hand if you want. It's a fun exercise. Sit down for a couple hours and calculate all of your assembly areas and all the U values for those areas and do the math. And this allows you to, as Meredith was saying, it allows for trade-offs. You can do less insulation someplace if you have more somewhere else. And you can use ResCheck or Ecotrope or RemRate. ResCheck, trade-off flexibility, comprehensive evaluation, and then it gives you a report you can print out. It's pretty simple. It's a pretty basic energy model, and it allows you to analyze your building, which is really useful for a lot of reasons, not only to make sure it gets to code, but allows you to play with stuff like, okay, what if I change the R value in my ceiling? How does that change the overall energy performance of the building? You can hand it to the code enforcement officer. All they want is that somebody else has figured it out, and you give them a sheet that says it's good. And they're like, yep, they put it in the drawer, check the box, that's fine. MUBEC, the way it works is it's required for every building in the state. But if your town has 4,000 or fewer inhabitants, they don't have to enforce it. Doesn't mean you don't have to do it, but there's nobody gonna come and check on it. So that's kind of a big carve out.
The elephant in the room is always enforcement, right? So you don't have someone to come check your house if you're a municipality of 4,000 or less, but it is law in Maine to build to code.
The 2015 target air changes per hour was 5 air changes per hour. Now in 2021, it is 3 air changes per hour. So it's the entire volume of air in the house is leaking out 3 times every hour or less. You see it says ACH 50. So that means that that's basically using the blower door to depressurize the house to 50 pascals. So one thing the blower door does, it basically simulates a 20-mile-per-hour wind hitting the house. As an energy auditor coming to a lot of different houses, that's pretty tight. You know, that at that point you need some mechanical ventilation, or else you're going to run into mold and mildew issues in the house. For passive house certifications, it's much less than that. So 0.6 is the leakiest house that you can have and still have get passive house certification. So there are different standards. If you have been building the same way for the last 30 years, you are not going to hit that 3 air changes per hour. You have to pay a lot more attention in detailing in the house, air sealing, looking for the places where you're going to find air leakage, not just in the envelope, but also in the mechanical systems as well. Number of different places that you can have air leaks in the building assembly. A lot of times you have air leakage coming in the basement, in the crawl space, through the windows, the rim and band joist where the house is sitting on the foundation. Air leakage coming in around windows and doors. A lot of times there's air leakage in the attic, all the tops of the interior walls, the tops of the exterior walls, top plates. There's usually a little bit of air leakage that goes through all of those spaces. And it may be just a 1/16 of an inch gap, but if you add up the area of all of the top plates for interior and exterior walls, it's a lot of air leakage. Chases for chimneys, for wire plumbing penetrations. You know when the electrician drills a hole into the top plate for a wire, they're gonna drill like a 1-inch hole and put a tiny little wire through and just leave it. And they don't typically air seal it. It's all of the little detailing work. Air sealing is very meticulous work. It takes time to go through and seal everything.